This computer. Hello, everyone. Welcome again to CE 528. And this is our first lab session, but we are introducing the whole course now. And as we do that, we're going to have our first lab assignment related to that. And the lab assignments will typically be due before the start of next lab. So you'll have some time to work on it outside the lab. I know some of you folks have some conflicting classes that you might be taking towards the end of the lab, and that's fine. So that's why I'll make sure that all the lab assignments are not due on the same day, but they're due at the start of the following lab. So, all right, so let's see. Okay, so here is the big overarching theme of this class, which is the systems approach and modeling. How do you take a systems approach to transportation systems and its modeling? Because transportation, we don't want to think of it always in terms of a facility, even though as engineers, sometimes that's what we are concerned about, designing one particular road or one particular parking lot. But if you're a senior this year, you might think about your senior project, right? So if you're designing a system, then that system has a lot of moving parts that impact a lot of different things and requires analysis of a lot of different things. And that's why a systems approach works really well. And that's kind of what the approach we'll be taking in this class moving forward. So CE 528, it's a course about how to make well-founded decisions about complex engineering systems. So why do something? Why do it now? Why do it in a particular way? Problems typically require structured thinking about large complex systems. So if you think about LA Metro, for example, or high-speed rail or interstate highway system, commercial aviation, Mississippi waterway, all these systems have individual facilities or individual aspects to them, but ultimately they function as a system. And then that system has to actually perform in an appropriate way for it to all work out. So engineering design problems, you think of that as spanning a spectrum, right? And nothing is really like, it's not binary that you either are talking about a facility or you're always doing a systems design. It's a spectrum and things fall where they fall. And there could be projects that you work on that really are limited, and maybe they have some implications for broader system, but they really fall to the left of this spectrum into the component and facility design aspect. Let me see if I can. So if you look at this, a component and facility design, let me see if I can. Yeah, so if you look at, I hope you're able to see my mouse. Give me a little thumbs up if you're able to see my mouse are you able to see the mouse cursor moving? Okay, good, very good. I wonder if there is a way to also do a screen pointer. Okay, yeah. So if you look at some things, here, what happened here? Sorry. Okay, so you can see like either I can look at it in, so some things, some projects might fall over to the left end of the spectrum because they really have that limited impact. Or there could be some other projects that fall into the way to the right of the spectrum because they really are a complex system. Okay? So when you're doing a component facility design, here are some of the characteristics you focus on. There are limited options. You focus on the physical laws and the codes and the standards, and then you minimize the resource costs while meeting the need. and you minimize the local environmental damage. But as you move to the right of the spectrum, you got wide latitude in options. You focus on the economics and the social issues as well. There are many dimensions of costs and benefits. You worry about widespread environmental impacts, changes to the society and the economy. So I think, and this is not like a objective scale as much as it's a relative scale. You're comparing different projects where they fall, and there's no objectively quantifiable way of what's a component design versus what's a complex design. But I think you can compare multiple projects. If you understand this whole spectrum, you can compare multiple projects and place them along this system. So for example, when you're building a metro system from scratch, that's a very complex system design. So it's going to fall way to the right of this, right on this spectrum. But if you're doing really, for example, if you're working on one intersection in city of San Luis Obispo, and you're making sure that that intersection is safe for pedestrians, then you're really dealing with that one intersection. Although, as we learn more about how the transportation systems perform, we really don't, I mean, sometimes we have to do it because our funding might be limited. But if you think of this in a safe systems approach that we talk about in CE 526 in the transportation safety class, we want to think about improvements from a systems approach as well. We really don't want to improve like one intersection unless it's absolutely necessary and we cannot fix everywhere. And then that's why we have to always do that. And that's okay, but this is something that we're trying to discourage now. It's just trying to fix one location at a time and sort of always chasing our tail. But there might be some cases, some applications where that's exactly what you're doing. You might still have to do that in some cases, and they fall to the left of the system. But I think in general, it's always beneficial to be thinking in terms of the system. So let's go to the next slide here. So systems approach to system planning. It's a classic rational approach to make decisions about the large system. What you need is a systematic process of containing a series of interconnected steps for reaching decisions. And we're calling it a systems approach and systems planning, but if you were to consult other disciplines of engineering, you might find that there is different terms that are used: systems analysis, systems engineering, general systems theory. But all of those, what they have in common is that instead of thinking about one element or one piece of the system, you think about the whole system, how the systems are interconnected. And depending upon the scope, the systems can be fairly large or they can be fairly small. So let's dig a little bit deeper into, or at least cursory, let's first quickly do a cursory review of other decision-making processes. So other decision-making processes are advocacy planning. Advocacy planning is about, you don't really know what's the best rational solution there is. So you put together competing solutions and then you just duke it out based on the skills of the advocate. So this is a lot of time what happens in the city council meetings, right? So a lot of times there will be alternatives. There is going to be people pushing it out and trying to convince the maybe the planning commission, maybe some other city council or whoever, and people just come in and try to advocate for their solutions that they want. And so that's one way of making decisions. And then obviously the scientific method that we use in most scientific research, most of the research in the pharmaceutical world, for example, you formulate the hypotheses, you collect the relevant data, and then you test the hypotheses. Then there is strategic planning. Strategic planning is basically and this is something strategic planning is interesting because you're not making decisions. You're not making decisions about a specific action. In strategic planning, you decide where you're going as an organization, and then decide on what's our strength, what's our weakness. And then anytime you have to make a decision, you evaluate that decision based on how far or to what extent it advances your goals that you've identified in your strategic plan. So strategic planning is something you do before you're making any specific decision. You have that strategic plan in place. And then as a new decision, as you face a new decision to make, you evaluate that decision from the perspective of, hey, does that decision meet my goals or meet the strategic objectives that we have outlined in as an organization? And then consensus seeking, this is Delphi methods. Delphi methods are interesting because what happens is that in Delphi method, you have a panel and you seek independent opinions of the panel. So everybody, so for example, let's say you're evaluating 4 or 5 different alternatives for a project. You give the panel all 5 alternatives and the salient point of those alternatives and have them choose, have that panel of like 8, 10, 12 people choose, right? And rank the alternatives. And they come back with their independent assessment. And then you make that assessment public, like, or not public, but you give it to the whole panel that, hey, this is where the average of the group lies, and this is what everybody else found. And then you basically let the panel rethink their decisions based on what everybody else thought. And once you see people's opinion, sometimes people are rational, and if they think there is value in what other people are thinking, and they change their decision, and you basically try to build consensus based on that. So these are sort of alternative decision-making processes that we might refer to in the class as we move forward. But our primary focus will be that systems, benefit cost, looking at the whole system and trying to make decisions based on the benefit cost ratios and some reasoning based off of that. Yeah? So that's kind of what we are trying to do. But we might refer to these alternative methods along the way. And again, this is not to say, yes, systems planning is probably the best approach for the transportation systems in a lot of cases. But it's good to be aware of these alternative methods because sometimes these might need to be applied. So here is the systems approach, like our flow chart, and there could be many different flow charts that can represent that process, and this is one of them. The first one is the problem identification, and then you define the relevant system. Problem identification, definition of the relevant system, and then I left a question mark, and then you analyze the alternatives, evaluate the alternatives, and you do the decision analysis and figure out, okay, what's going to happen here. So what do you think is missing? What do you think is the missing step? You can type that up in the chat. What should fill that question mark? What step is missing in this flow chart that is represented by a question mark? Please type that in the chat box if you can. So in terms of, so generating solution alternatives was a step that was missing there. And then it's followed by analysis of alternatives, evaluation of alternatives, and the decision analysis. Now, if you look at these three, they look pretty similar, right? They in fact, if I were a layperson and I read those three, they almost feel interchangeable to me. Would you agree that they seem somewhat interchangeable, those three terms? Analysis of alternatives, evaluation of alternative, and decision analysis. Do they seem sort of interchangeable to you as you read through those? Yes or no? Maybe in the chat box. I'll give you a 30 seconds possibly. And if they don't seem interchangeable to you, what do you think is the difference? So what I want you to think about is the next 3 steps in the flow chart, the analysis, the evaluation, and the decision analysis. Do they read like they're interchangeable with each other? Or do you think they could potentially have slightly different meanings? And if they do, which obviously they do because they have 3 different points in the flow chart, what is the difference? What do you think is the difference? Any thoughts on that are welcome. Again, you can unmute yourself and talk, or you can try to type that up in the chat box, please. All right, so I didn't hear any responses. That's okay. What I think, I'll give you some things that you might do with the alternatives. So one of the things that you could do is like you might assess their basic feasibility. Is this something that's even conceivable to do in this situation? And then you might do some number analysis where you can evaluate the net present worth, benefit cost ratio, internal rate of return. And then once you have all those metrics, then you might pick, okay, what works best. So the 3 steps that I outlined, so basic feasibility, that might be the analysis of alternatives. Analysis of alternative might involve looking at, how much labor would it take and how much capital cost it would take. What's the money that I have to spend today? What's the money I'll have to spend on moving forward every year to maintain something? So that's your analysis. And then you take all those analysis numbers and then come up with measures like benefit cost and net present worth. That's your evaluation of alternatives. And then once you have all those parameters like B by C ratio and IRR and all those things, then you pick which alternative to pick from all the available alternatives, and then you implement and monitor. So that's the difference. In analysis, you're basically detailing the details of each alternative and judging basic feasibility. In evaluation, you're coming up with metrics like what you learned in engineering economics. And then in decision analysis, you're picking based on the B by C ratio, because sometimes you might feel that the decision analysis is fairly trivial. We just pick the one that has the best benefit cost ratio. But as you will learn in this class, benefit cost ratio sometimes doesn't work. It's not the best way of picking alternatives. So there is some more to decision analysis. And once you have the decision made, then you implement and you monitor. And then obviously you seek feedback, and then there will be new problems, and then the loop cycles through. And then there are some dashed arrows here in the chart that represent that sometimes you might be able to skip certain steps. And then once you evaluate alternatives, you might have to go back to the drawing board and generate more alternatives. And then if you do the decision analysis, sometimes you might find, hey, none of these really work for us. So we might have to define the system again. So there could be some jump between these different ones, different points of this flow chart. Now, my question to you is, can you now identify what is the difference between analysis, evaluation, and decision analysis? Yes or no, please, in the chat box. Okay, I see some thumbs up is fine too. So if you're doing thumbs up, that's great. Now, if you don't think you can outline the difference between analysis of alternatives, evaluation of alternatives, and decision analysis, if you can't differentiate between the 3, could you ask me a specific question? What's bothering you about that? If you cannot, if you are one of the people, anybody who still, okay, so you can put the thumbs away now. That's great. So now I want you to raise hand if you cannot tell the difference between 3 steps. Yes, I see something in the chat there. Okay, so great question. Where does uncertainty comes in? Yeah, that comes in typically in the decision analysis. So in decision analysis, you might, and it could come in also in the evaluation of alternatives. You might evaluate alternatives at different levels. So for example, if there is uncertainty about interest rate, you might evaluate alternatives at different interest rates, right? So uncertainty could come in at the evaluation of alternatives, or it could come in at decision analysis point. And we'll talk about the uncertainty and making decisions in the case of uncertainty. So what we'll do is like, I'll give you the evaluation of alternatives in terms of their individual payoffs. And then we'll talk about how to factor in the risk of different scenarios panning out, right? So yeah, so uncertainty mostly comes in the decision analysis, but sometimes you can incorporate some of the uncertainty, like the interest rates and so forth, as part of evaluation of alternatives as well. Does that make sense?
Yeah, that makes sense.
Perfect. Any other questions? So if you're one of the people who hasn't quite grasped the difference between analysis, evaluation, and decision analysis, please leave a note for me in the chat. Maybe you can just drop a private note and I'll just try to explain on that question. But I would really appreciate any specific questions that you might have, like it was asked just now, like where does uncertainty come in, and so on and so forth. So really appreciate a specific question if you cannot quite grasp the difference between the three. Give me maybe another 30 seconds. And after that, I'm going to assume that you folks all understand what's going on here. Okay. All right, that's good. So we'll move on. So this is sort of your framework here. And this is from your textbook that you could look at. And this is figure 1.7 from your textbook. And then when you, so this is another way of representing the same thing, but now just with more details. And it could be single year or multiple year alternatives, evaluation, different aspects of that. And then economic efficiency, effectiveness, equity, financial feasibility, all those different things. And then this is sort of analysis of alternatives where you come up with the determination of demand, monetary costs and benefits, and all those other different things. So this is sort of filling in the details that we are trying to fill in, that were shown in the previous chart. Okay. And then you could see that when you're looking at the analysis, you're looking at technical impacts, environmental impacts, ecological impact, aesthetic impact, social impact. So there is a really whole host of dimensions there that need to be accounted for, depending upon how broad your system is. And obviously, if you take into account fewer things, decisions are simpler, but they may not be the best decisions. And that's the trade-off. Like, you know, if you do more detailed analysis, more complicating things, and sometimes that could be frustrating, and that's just how the things are. But that doesn't mean that you can short circuit the process. So you have to, and therein lies the challenge. How do we do most comprehensive analysis that's possible and still get something done? And it's possible, certainly, but it's something that you have to work towards. Now, the next thing is that, you know, how do we define the system? So how do we make sure that we define the system as the correct way? Because again, if you define the system too broadly, then the analysis becomes too unwieldy. So system definition is a collection of components which are meaningfully connected and bounded, and which function together to meet particular objectives. But the problem is, how do you make it appropriate and efficient at the same time? There is a trade-off. Like the system, if you make a very broad definition of the system, you might be more accurate in your definition. However, it might be a very inefficient process for that, because the system will become too unwieldy. You cannot track everything, all the impacts, and that will be problematic. So it's kind of like defining the scope of the problem. What are you going to take care of? What's in your hands? And what you're not going to simply worry about. There's some things that you cannot worry about, and then you just let those things go. And you don't consider them part of your system. So here is an example of the slow transit. San Luis Obispo transit system. It's operated by First Transit here in the city of San Luis Obispo. It's a system existing for the purpose of providing mobility to local residents and visitors. Slow transit is also part of a larger system of all slow county transportation services. The bus operator, the First Transit, is another system, is a part of subsystem of slow transit. So what is the correct system definition here? How do you decide? Should you include the whole county's transportation system as part of your system? Should you just consider the city? Or should you look at the bus operator company, the First Transit, as my system? How do you decide on that? What are your thoughts? What are your thoughts on how do I decide what is an appropriate part of my system? That's exactly right. So Alexandra says, I feel like it may depend on the problem. That's exactly right. I mean, your systems are not going to be defined in a vacuum. Your system has to be defined in the context of the problem you're trying to solve. For example, if I'm trying to figure out, so one problem that I noticed with the slow transit system, and it's not an easy problem to solve, by the way, but it's a problem nevertheless, is that our buses that serve Cal Poly during the morning rush hours, they're jam-packed. They're people sort of just barely hanging on and standing room only. And sometimes the drivers, I've had that happen as well. The drivers have to turn away passengers and have them wait for the next bus. The buses are so full. However, at the same time, the buses are not so full pretty much any other part of the system, any other time of day, or I see buses running empty all the time. Once you sort of get out of the Cal Poly's boundaries, or where most Cal Poly students live, if you get out of that boundary, the buses are running empty. So it's a very inefficient allocation of resources in that way. So one problem is, how do we make sure that we can fix the schedule in a way that we are serving all the passengers, yet at the same time, we're not running buses empty in the other part of the system. And there might be solutions related to, on-demand transit, like maybe contracting with micro transit companies like VIA and so forth, that can serve other parts of the system with using different approaches, maybe some on-demand transit, and then you provide more buses in the morning peak hour to the Cal Poly, in service to Cal Poly. So maybe you run multiple buses on the same route at the same time, or something like that. So there could be solution that involves collaboration with microtransit companies. And in that case, your system might just be the city of San Luis Obispo bus routes, right? And that's exactly what you focus on. But let's say if the problem is that the slow regional transit authority, because they have a dual mandate, they want to serve the people who are working downtown, but they also want to serve people who live in the North County or South County, but work at Cal Poly. But the morning bus has to schedule both. And slow transit wants to help slow regional transit authority serve both of their ridership, the ones that want to go downtown in the morning and also the ones that want to go to Cal Poly in the morning. So that's where the whole county systems now becomes part of your system. And what you could potentially do is maybe you can provide a transfer bus service that services on right at the 101 exit on Monterey Street, right? Where the RTA bus can come from North County, or even the buses that exit from South County. The buses can come in, and there could be a slow transit bus waiting for those riders that get off the RTA bus and come to Cal Poly. And the RTA bus can directly go to downtown, or vice versa. The RTA bus could go to Cal Poly, and all the downtown residents could get off and go run. But in that way, the system would include the whole county's regional transportation authority, the whole county's RTA, right? And just it just depends on the problem that you're trying to define. Now, the first transit might be concerned about driver shortages, for example. So they might want to be privy to the services that they provide, but they might want to focus more on their internal processes as to how do we hire drivers, how do we train drivers, and so on and so forth. Once they've figured out the demand, then they might have to have some internal, programming to deal with, or internal system to deal with, as to how do we provide efficiently the drivers that we need, right? So then they might want to focus a little bit more on their subsystem of their operations. So Alexandra, your point was very well defined. Like, it depends on the problem. I just gave you some example of problems as to how do you define the system. I hope that makes sense. Any questions about that? Any question about the system definition? I'll give you again about maybe 20 seconds to raise your hand or type your question in the chat. And you're always welcome to type the question just directly to me and not to the whole class if you feel that that's important for you. Very good. So here are some formal steps to define the system. Obviously, the first thing is the system objectives. They relate to the problem at hand. The environment of the system. Environment of the system, it's some things that are outside of your control. So they are just environment. They're just external factors that you cannot control, but you have to account for. Structure of the system, that's your inputs and output. They're necessary for modeling the system. And then you have the constraints on the system, internal and external constraints. And then resources available to the system. That's basically any of the grant money that might be coming in your way and things like that. What else? What do you think is something else that must be known to understand the nature of the system? Any thoughts on that? So as you're trying to define a system, what else might you want to know about your system? Any questions, any thought on, again, I'll pause the recording and give you maybe some time to think about what else might be needed. So what else must be known about the system? And the response that I had was, in fact, the correct one. It's the managers. Who controls the system? To what extent? And that question is important because that determines the boundaries between the systems and the environment. So managers, the people who control the system, maybe control the purse strings, maybe who control other decision-making around the system. That question, so managers, you can think of them as sitting between the system and the environment. So they're right at the boundary. They're in the system, they're part of the system, And that boundary determines what's the environment and what's the system. Because remember, the environment of the system is outside your control. So what we was missing there is what else must be known is like who are the managers and to what extent they have the control over the system. Let's think about the hierarchy in the system's objectives. And this relates to your lab, really, this slide, your lab 0 assignment. What are the values? What are the shared notion of what's good or bad? The general statements of what's to be accomplished. So if you look at this slide, if you start with the first bullet point, really high level values, shared notion of what's good, what's bad. And this is not something that you'll be able to directly measure. This is like, if I'm being facetious, I could call it like more touchy-feely type stuff, right? These are the values that we want to prioritize. And if you come down one step, so basically what you'll see is that as I go down the bullets in this slide, I become more and more specific. Things become more and more quantifiable as you move down the bullets on this slide. So values are really touchy-feely, long-term, shared notion of what's good, good or bad. And then we come down to goals. Goals are still general statements of what's to be accomplished. To be consistent with our values, what really do we want to do? And now you get to the objectives. Now these are goal-derived statements whose achievement can be measured. So once you get to that objective step, now you're getting to something measurable, something that you can really quantify and measure. And then measures of effectiveness and measures of performance. These are dimensions by which degree of achieving each objectives are measured. May involve specific targets. They may incorporate standards, which are thresholds between acceptable and unacceptable values. So for example, airlines always have some targets about, what percentage of flights they're going to have delays. And I'll tell you an interesting thing. If you have experience with flying, and I know last couple of years have been kind of none of us have flown all that much. But if you think about it, you think most planes, they land on time, or like, are they late, or do they land like way before? On which side? So usually when you ride a plane or you take a flight, they have a scheduled time of arrival, right, to the destination. And my experience is that most planes land way before the scheduled time, mostly early, and that's exactly right. So I see most of you are saying that they land mostly early, and that's right. And you can probably guess why that is, right? And that actually relates to this idea of measures of performance. Why do you think most planes land early? Earlier than their scheduled time at destination.
Is it to make sure they meet a standard?
Yeah, so basically what they do is in their scheduling, yeah, you're almost there. In their scheduling, they built in a lot of slack time. Not a lot of slack time, but they built in some slack time at least, so that their on-time performance, their measure of performance is met. And obviously they don't want to have too much slack time, because then there might be inefficiencies that they still want to be efficient, but they do build in some slack time to make sure that they're meeting their standards for on-time performance. Right? So if they build in some slack time, they mostly land early, which is okay. So at or on time. So they're not very aggressive in their goal setting in terms of what their arrival time would be for their destination. And that relates with them being able to meet their measures of performance. And in fact, your first lab or your 0th lab, like what we're going to talk about today, we're going to learn about different transportation systems in America that are functional, and some great things about them overall. But then we're going to Based on that, we're going to try to come up with some performance measures for the transportation systems that we observe in that video. Okay? So that's going to be our lab. And so here is just some example of how that hierarchy of goals that I talked about might look like for slow transit, for example. It's a bus system. So your value might be people should be allowed to live independently and with dignity. So regardless of whether or not you can afford a car or you can drive, you're able to live independently and with dignity. So then, what does it mean to live independently and with dignity? Then you define your goal. To live independently and dignity, you need mobility regardless of age, wealth, or infirmity. So that becomes goal again, still not quite measurable. Now you get to the objectives. Provide economical door-to-door transit service with accommodation for handicapped people, or for people with disabilities. Okay. So objectives. So when I say economical door-to-door, I should be able to measure the cost of each ride that people experience. And then go from there. And so again, we're getting more and more specific as we move down. My question for you now is, in the chat, I would appreciate you guys thinking about how do we measure that objective? What are some of the measures of effectiveness and measures of performance that I could use to figure out whether or not I'm meeting those objectives? Give you another, I'm going to pause the recording, give you some time to think it through and provide some responses in chat. Okay. So yeah, so saw some good responses here. The user satisfaction survey, how many people are able to live in a survey area within a quarter of a mile or certain defined distance of a bus stop, or yeah, that's good. And then cost and fares, wait times that people have to wait. And you could also look at, service frequencies, and that obviously will dictate the wait time. So yeah, some good responses there. Thank you very much for engaging with that discussion. This is good. And here is what I have on the slides. Response time, fare, cost per ride, coverage area, peak hour capacity. And if you're actually dealing with accommodating some on-demand transit services, that'll be the number of unmet requests. That could be another one of those. And that's pretty good. So do all of these make sense? Anything that was not yet covered? So maybe some of you are thinking about some measures of effectiveness or measures of performance that didn't get covered either in the student responses that you saw that I talked about, and then also that's listed on the slide now. Are there things that are still missing? There might be, there should be. Does something come to mind that might be missing? You could also look at, like, for example, transfer options, right? So that, we didn't talk about transfers here, but if you have to change the bus or whatever, number of missed transfers or things like that. Because if one of the buses gets delayed, then you miss your connection. So that's a missed transfer. And making sure that there are fewer of those is a good thing. So that's one thing that was probably missing. So if there is another thing that comes to mind, let me know. Okay, moving on to the next slide. Some issues related to system objectives and MOEs. Many decision makers do not want to reveal objectives and target upfront, because if they reveal it upfront and they miss it, that's not an ideal situation for the managers. So sometimes they only reveal whether or not they met the target. They only reveal if they meet the target or something. So they don't. Objectives often conflict. So for example, we saw some measures of effectiveness and measures of performance. The cost per ride probably increases if you increase your coverage area. So you're gonna maximize the two, but there is a trade-off involved. So there's often conflict between different participants, often for specific individuals. There might be different conflicting objectives. The target values for measures of effectiveness should be used with care to permit study of trade-offs. So if you're going to have target values, you cannot just have one target value. Maybe you have to have some kind of a trade-off involved, like, okay, what's the target based on what's the on-time performance given this cost, right? So you might have some study of trade-off, like, okay, at this budget, how many passengers were we able to serve? And things like that. So there have to be some accounting for trade-off involved here. Okay. Desirable properties of the measures of effectiveness. They have to be appropriate and relevant. So they have to reflect at least one important goal or objective. They have to be measurable and clearly expressible in an unambiguous manner. They should match the scale of alternatives being compared. So if you are gonna make changes to the system, you have to make sure that you're matching the temporal scale or a spatial scale of the alternatives being compared. So for example, if you wanna look at the annual benefits and annual costs, you should be able to make that annual comparison. And your measures of effectiveness and measures of performance should be realistic to measure. It shouldn't be like something that you have to spend so much resources to measure that you're exhausting almost all of your resources in just measuring what you're doing. So they should only require MOEs and MOPs. Measures of effectiveness should only require a realistic effort to estimate. Clear and easy for lay participants to understand. And then forecastable to the time horizon of alternatives. Like, okay, if you're doing it for the next 5-10 years, you should be able to identify those for that time horizon. So these are some desirable properties. So in the lab 0, I'm going to ask you to list some MOEs for the transportation systems. So make sure that the MOEs that you list sort of meet this criteria. So notes about system constraints. So before I do that, let me go ahead and introduce your lab 0 assignment to you. I'm going to pause the recording, or I'm going to pause the sharing from here. And I'll go back to the lab. So in lab 0, what I'm asking you to do is that I'm going to show you this video here. And you can go back from the start. And this is about America's transportation system. It's a 53-minute video that I want you to watch. And then once you watch the video, you'll get introduced to different transportation systems and their inner workings. And I want you to write 2 measures of performance or measures of effectiveness for each of the system you observe in this video. So it's going to involve a 50-minute video watching, and then individually looking at, for all the systems that you see, come up with 2 measures of performance for those systems. Okay, and then what transportation systems are missing from this video as well. So those are the 2 questions you need to answer, and that's your first lab assignment. What I'm going to do is, like, it's been like almost 1 hour since we've been talking, so I'm gonna go ahead and take a break. If you want to get started on watching this video, that's fine. But once we come back from the break, we'll continue the discussion. But I would really request that maybe you take a break as well. And then maybe we gather together. This is 9:10 right now. Let's gather together at 9:25. Okay, so maybe take a 13-minute break. Maybe go see the sun outside. Just take a little break, and then we'll come back at 9:25. If you come back quickly from the break, just feel free to watch this video. This is from a PBS show called America Revealed that they had like a few years ago, but still has some great insights about how the transportation systems actually perform. So you can go ahead and start watching it, but you don't have to right now. But we're just going to take a break. Okay. So I'm going to pause the recording. Okay, welcome back. And what we're talking about now is the system constraints. System constraints could be physical, economic, financial, political, or environmental. Objectives with firm self-imposed targets. You can think of those as a constraint as well. Like if there are targets that you must meet, they're no different really than a constraint, right? So they become related to the constraint. And there are typically constraints related to system resources, which may be either inside or outside the system, depending upon the degree of control by the system managers. So these, this could be like, you might be limited by the funding, but the legislature has says that, you have this funding, but you have to use it by a certain time period. So there could be that. So these are all sort of different constraints that you might have to work under. Classification of the system, you could classify them. There could be multiple taxonomies that you could use to classify your system, open or closed, for example, the degree of interaction across the system boundary. What happens in the system boundary? Can you join and cross into the system boundary easily? Or is there, so think about Los Angeles area freeways, it's an open system, but Disneyland is a closed system, right? Because they control the entry and exit in a significant way. It could be stationary or a time-dependent system. There could be, if you're talking about freeways as a system of traffic operations, it's a very, very dynamic system because traffic operation changes over time very, very quickly. But it could also be a stationary system if you're thinking about, the design of the freeway, like, that doesn't change very often. Adaptive and non-adaptive system, the airlines, right? Very adaptive system. They change routes all the time, depending upon the demand. They add flights, they remove flights. If you think of pipelines that transport maybe fuel from one location to the other, they're kind of like a transport system because they're transporting some goods from one location to the other. But they're very non-adaptive. Once you've built the pipeline, that's it. You cannot even use it to transport anything else, right? If you have pipelines, they're built to transport one thing, that's exactly what they're going to be able to transport and nothing else. So they're not very adaptive in that way. So they're non-adaptive systems. So, and deterministic versus stochastic. Stochastic systems have a degree of randomness associated with them. Urban traffic systems, very, very stochastic in nature. For all practical purposes, there is a lot of variation from day-to-day demand. Like this Monday is not going to look exactly like last Monday. There's going to be some random variation within that. So there might be some systemic variations that occur because of like maybe a Labor Day type Monday that happens. But then also there could be random variation between week to week. There are just noise in the system. So, and anytime we have that kind of noise in the system, we call that system to be stochastic in nature. We can classify models, and this is something that we learn about in our modeling and simulation class as well, is that what's the purpose of the model? You can classify your system based on the purpose of the model and then substance of the model. So you can, from the purpose of the model, you could have descriptive, analytical, or optimization model. And then the substance of the model could be, it could be a physical model, it could be a logical model, or it could be a mathematical model, right? So how the model is built is on the sort of the y-axis, and purpose of the model is on the horizontal axis. And you can sort of place models. So think of that as like 2 dimensions, like X and Y scales. And you can start to place any kind of model that you have. It could be a physical model designed to be descriptive, right? So you place a model on the top left box there. But if it's a mathematical model designed for optimization purposes, then you place that model to the very right end of the spectrum. And then there could be things in between as well. So that's just two axes of classifying the models based on their purpose and based on their substance. And you could start placing the models at different aspects of these dimensions. Analysis of the system. Analysis involves estimating the consequence of alternative actions taken to improve the system. It could be future consequences. The distinction is that these consequences are not directly useful for making decisions, right? So in this analysis, we're just finding out what's going to be the benefit of that, just the annual benefits. So that's your analysis. Annual cost, that's part of analysis stuff. These consequences are not benefit cost ratio. Okay? So that's where the evaluation comes in, as I explained earlier. The consequences that we talk about in the analysis step, they are about just the measures, the benefits, the payoff, things like that. But then when we evaluate, then we come up with different measures like benefit cost ratios and so forth. There are three critical aspects when you evaluate system alternatives. One of them is that the consequences of each alternative, they have to be based on the same measures of effectiveness. So they might inherently reflect some good or bad performance. And then when you're doing system evaluation, you want to highlight those trade-offs. Comparisons and trade-off among alternatives have to be highlighted. And then the material should be put in terms of easily understood terms for the intended audiences. And these could be political decision makers, political actors. So you have to make sure that everybody understands what you're talking about as an analyst. So these are the three critical aspects. Everybody should be able to understand that material, whatever decision-making aspects you're putting out. You have to highlight the comparisons and trade-offs between alternatives. And all alternatives should be evaluated based on the same measures of effectiveness. But if you can't do that, then those alternatives, maybe you cannot compare them appropriately. There are some additional issues with evaluation. You have to have the robustness of comparisons and trade-off to risk and uncertainty. You have to have that. You have to test for project feasibility financially, legally, administratively, and politically. If there's no point in doing evaluation if your project is not even feasible at all, right? So you want to make sure that alternatives that you're providing, you can think of that as passing the smell test, right? If they make sense at all. So they have to at least meet that feasibility criteria. If public is so opposed to it that that's not going to pass muster at all with the council, with the city council or whoever, or the planning commission, then that project is not politically feasible. So all your evaluation might mean nothing if it cannot garner any kind of political support. If it's a political non-starter, or if it's an administrative non-starter, then it's just not going to happen. And then obviously we have to talk about uncertainty as well, account for uncertainty in some ways as well. Principles of evaluation. Decisions are among alternatives that should be clearly identified. They should be comprehensive in scope, and you have to make sure. There is always this bias towards doing something, and because analysts have that bias, because because you're engineering students or planning students, you're going to start your career as analysts mostly. And when you're young, you want to do something. And these analysts always have this bias towards doing something. But that might not always be the right course of action. So you have to include some no-build, some low-cost, and some imperfect options that might not do everything. They have to be comprehensive in scope in that your evaluation has to be comprehensive, but then it doesn't mean that you don't evaluate the low-cost or imperfect options. You have to include them in your evaluation. Furthermore, decisions should be based on future outcomes of alternatives. Past history is not really relevant. except as it might affect the future. So you have to be, this is what I'm trying to make you beware of, the sunk cost fallacy. So, just because you've taken some steps in some direction before, doesn't mean that you have to continue with those steps into the future. So that's your sunk cost fallacy. That's because you've already done something. Doesn't mean you have to continue down that path. So for example, you only have to worry about, if you've had a failed initiative in the past, that failed initiative is only relevant if it affects the future. So initiative that might have failed in the past might still succeed, but because you have a history of failed initiative and you go to borrow money from some bank or some financial institution, and they look at that history and charge you a higher interest rate, then yes, your past failures are in fact relevant because they increase the cost of borrowing the money and then they increase the cost of the whole enterprise. But other than that, past failures are not really relevant. So past history is only relevant if it affects the future. If it doesn't, then don't worry about those. Alternative viewpoints should be identified, and impacts on different interest groups should be sometimes evaluated separately. And again, that's where equity questions come into play. An impact should be commensurable. So you might want to convert them into dollar amounts or some sort of sliding scale as much as possible. And we're going to do some examples related to this as our homework problems in the future. So we'll do that for sure. So impact should be commensurable. They should be measurable against each other as much as possible. So what I'm going to do is I'm going to stop here with the lecture because this is kind of relating with your next homework problems and so forth. So we'll stop here. So there is no other homework problem that I'm assigning right now, even though if you look at the last slide of the slideshow, you might see a homework problem, but I'm not assigning that to you just now. I'm going to stop here with the lecture. But now what I want to do now is I'm going to stop the recording here. I just pause it. And I'm going to play the video, at least for one transportation system. And I want to talk about some measures of performance. So I want to watch a portion of that video that I'm going to assign you for lab 0. And then based on that video, we're going to start to try some measure performance for just one of the transportation systems. So we're going to start watching that video for a few minutes until they talk about at least one transportation system. We're going to try to write measures of performance in the lab right now. And then that will give you some ideas about how to proceed for the other transportation systems. Okay, so I'll take a 1-minute break. I'm going to set up that video watching, and then we'll go and start writing that. And then you'll submit the rest of the lab before the start of next Wednesday's lab session. Okay, make sure you submit that before the start of the next lab session. Okay? We'll go ahead and pause recording. Resume recording. Go back to the beginning of this video. So we're going to watch first few minutes, or at least until they discuss one of the transportation systems. And then we'll try to work out the lab assignment for that. Okay? So let me go ahead and play here. Can you get the sound? Give me a thumbs up. Give me a thumbs up if you can hear the sounds. No sound? If you're not getting the sound, please. Oh, no sound. Okay. Let me pause it and make sure that we can get the sound. So I might have to stop. I might have to stop the share and reshare. Share sound. Go ahead and play from the beginning. You get the sound now?
Welcome to the series that takes you to the heart of America and reveals the inner workings.
Okay, so I've increased the volume. Let's see if that works now.
As you have never seen them before. I'm Yul Kwan. I've worked in many different fields, from law to government to business.
It should be better now.
I've even won the
not
reality
that you know
show
the channel.
Survivor. But in every part of my life, I've been fascinated by the same things: systems and networks. We're going to go on quite a journey, coast to coast, across this sprawling land, to discover the habits, the rhythms, and the secrets that you only notice when you step back and see the big picture. The interchange is oddly elegant. In the next hour, aerial photography and satellite tracking will reveal how America's transportation systems make us the most mobile people on Earth. We've built vast networks of roads, rails, and airways, and an army of workers keeps the wheels turning. Hey, who here likes Mike the bus driver? But it's getting harder and harder to keep all these systems running.
Well, I think the freeways will get so slow where a lot of people have just decided it's not worth the grief.
Many of them are aging, designed at a time when America was far less crowded.
You have a disruption in one place and it ripples all the way across the country.
It does have a ripple effect.
But even as they struggle to keep up, every day our systems miraculously manage to get us where we need to go. This is a story of 310 million Americans on the move. This is America Revealed. America Revealed is made possible by the Corporation for Public Broadcasting and by contributions to your PBS station from viewers like you. Thank you. Monday morning, just before dawn. But this isn't the night sky. This is America. This is us. Each of these points of light represents 7,500 people. They create brilliant constellations that span the continent, from the faint glow of small towns to the blaze of cities like Chicago and New York. To connect these dots, we've built 4 million miles of roads, 200,000 miles of rails, 5,000 airports, the largest transportation network in history. But keeping it all moving, that's America's challenge in the 21st century. And nowhere does that challenge loom larger than in New York City. It's the perfect example of a powerful but aging transportation network that moves millions even while straining under their weight. Take the island of Manhattan, 23 square miles, home to 1.6 million people. Every weekday morning, its population nearly doubles, swelling with an army of commuters. These people are essential to the life of the city, but getting all of them onto this tiny island in only a few hours is a daily adventure that teeters on the edge of chaos. And it's about to begin. It's 6:13 a.m. I'm coming in on the red-eye from LA to JFK International Airport, and I've got plenty of company. We plotted the paths of every plane landing at New York's 3 major airports in a 24-hour period. A flight comes and goes every 24 seconds. That's more than 3,500 flights a day. By 7 a.m., thousands of yellow cabs are picking up their first fares of the day at the airports and heading for Manhattan. This taxi is one of 60,000 vehicles that will weave its way through New York's necklace of bridges and tunnels in the next hour. Just below these bridges, more than 100,000 people are traveling to and from the island by boat. These are the traces of those vessels darting around New York's rivers and harbor, including one fleet which alone carries 65,000 commuters a day. The Staten Island Ferry. As thousands descend on the island by air, road, and water, even more arrive by rail. Long Island Railroad trains carry suburban commuters into Manhattan every 2 to 4 minutes, along with packed trains from New Jersey and Amtrak trains. They all converge at America's busiest commuter hub, New York's Penn Station. While only a few blocks away, trains from the north stream into another bustling train station, Grand Central Terminal. But getting people onto Manhattan is just half the battle. Now they have to deal with this. The streets run yellow with taxis, competing with thousands of trucks and cars. And bus routes crisscross the island, adding another layer to the traffic. I'm not surprised the word gridlock originated here. It's 8 a.m., and it looks like nobody's going anywhere. But beneath these streets, it's a different story. I'm talking about the subway. Every day, this system carries over 5 million passengers citywide. Without it, traffic would overwhelm Manhattan streets and the city couldn't function. But the subway has had an even bigger impact than that, starting in the early 1900s when the first track was laid. If you build a transportation system in America, whole cities and towns will spring up around it. The subway system is a prime example. It determined how New York City took shape and dictates the patterns of its inhabitants' lives. Look beneath this forest of Midtown Manhattan skyscrapers. Multiple subway lines converge here, funneling in hardworking commuters from the city's outer boroughs, like Queens. This is a snapshot of what Queens looked like in 1917, when subway construction was just getting started. And here is what it looks like today, a busy, vibrant borough. The subway made Queens possible. But how? 100 years ago, to combat overcrowding in lower Manhattan tenements, New York expanded its fledgling subway system into the sparsely populated outer boroughs. Critics call them the tracks to nowhere. But New Yorkers soon got on board, lured by the promise of open land just a short ride from their jobs. By the 1920s, these lines were carrying more passengers than they could handle. The city planned to add over 100 miles of new track, but first, the Depression hit. Then, World War II. Today, we're stuck with the same basic rails that were out of date in the 1930s, and the number of passengers keeps going up with every passing decade. It's a pattern we'll see all over the country. Enormous but aging systems working harder and harder to keep up with the growth they help create. It's 10 a.m., and the morning commute is winding down. The city has survived another rush hour, and millions have made it to their destinations. New York's public transit system may be old and crowded, but without it, this teeming metropolis would come to a screeching halt. The same is true across the country. Our public transportation system.
Okay, that basically they covered one aspect, and I'll let you guys watch the whole video and kind of dig deeper into different aspects of the US transportation system. So let's talk about the lab assignment, the lab zero assignment I have for you is that thinking about the New York subway system, one of the systems that they covered in here in this video so far. And they just kind of talk obviously about the broad brush. And this is obviously and one thing that you might have noticed, a couple of things I want to bring along to your attention, and that this was done, I think this video is from 2011, I believe, so some time ago now, but the subway system still functions the same way in a lot of ways, but some more challenges have become apparent since then. And you could tell that this is an older video because they don't mention any of the transportation network companies. They're still talking about the cabs, which are still there. And in fact, they're making a resurgence now in some ways because, because of the problems sometimes the Uber and Lyft are facing now. But anyway, so because they don't make a mention of it, you could tell that this is somewhat of an older video. And then since this video was made, one more aspect that New York City subway deals with has become apparent. I don't know if you saw recent videos of the station flooding, and that sort of is like, what happens, but like, that the events that we used to think of them like completely outside of the mainstream are happening more and more often now because of climate change. And then the station floods, that creates a lot of its own problems, even, so how do we assure, so we have to learn from other systems like in Japan, how do they deal with all those problems? So these are a couple of big changes that have happened since this video was recorded. But my goal is not to actually talk about the new changes or that have happened since then, but my focus is for you to think about the New York City subway system and think about the two measures of performance that you might use to evaluate its performance, right? So that's one thing. And then, yeah, so that's basically one of the things that you need to do here for assignment. And once you watch the whole video, think about what transportation system they didn't talk about in detail. I've already given you some hints there. So hopefully you'll be able to complete the assignment. So let's work on that part, like what are the measures of performance for the subway together. So why don't you drop in some measures of performance for the New York City subway in the chat, either to me privately or to the whole class. I'm okay either way. So let's go ahead and think about those things. And if I'm satisfied with the responses, I can leave you to this lab assignment to work on. I see one chat response. So I see one of the chat responses, peak hour capacity. Obviously, we need more. Yeah, peak hour capacity could be one. I don't want to go ahead and pause the recording for now, and then we can wrap up with the final recording later. So I heard some good comments from you guys about some performance measures. So I'm going to go ahead and talk about those real quick before we wrap up the discussion. So one of the things that, yeah, the on-time services is a good one. Peak hour capacity is a good one. Peak hour demand and how many passengers would actually move during peak hours would be a good one. There was one that is about service range, and that could be interesting to evaluate future expansions, like how many people are able to live within quarter mile of your destination, and then you can evaluate alternatives of expansions based on that. And then important to think about that there might be costs associated with that. Like, if you try to expand where there is already dense development, then there might be more expensive to expand service there. But again, that highlights trade-off, and that's a good thing. So you could definitely look at that. One interesting one that came out was amount of people who couldn't get on the train because it was too full. But think about how hard it might be to measure. So we always have to think about, can we measure the measure of performance with a realistic effort? So these were some of the things that we learned about for the New York subway system. And these are all decent performance measures that you can note. So it looks like you guys have the hang of what you need to do for this assignment. So go ahead and watch the full video at your convenience, and then go ahead and submit the assignment. Are there any questions from the audience that I could answer for the YouTube video that I'm going to post for this lab session?
For the answers, is like what we were putting in the chat fine, or do we need to go into like a more in-depth discussion?
No,
for-
just bullet points are fine, unless there is some trade-off that you want to highlight or whatever. Just the bullet points would be fine.
Okay, thank you.
Thank you. Any other questions? If there are no questions, I would like to thank everybody and just stop the recording. Or at least pause it for now. So the question from one of the students, one of your colleagues, was that, what's the difference between analysis and evaluation when they both talked about the consequences of the system, right? In the slides, we mentioned consequences of both systems. So in the analysis steps, when you talk about consequences, what I mean by those consequences would be the cost, the annual benefits. You could talk about in the analysis steps, you might talk about the ridership served, how many people were in fact served by your system, things like that. How many hours of delays that were avoided because of that? What is the travel time saving because of your alternative, things like that. But when you get to evaluation step, now you translate all of that into like a benefit cost ratio or an internal rate of return or a net present worth. So you take all those consequences, those individual consequences, and you package them into one measure, like a benefit cost ratio, and multiple measures really of benefit cost, of net present worth, that you can directly use to make decisions. Does that make sense? Right.
Yes. Mhm.
Right. So when you talk about consequences in the analysis steps, I'm talking about individual consequences like riders served, travel time saved, cost savings, or actual costs involved. And so when you do that analysis, and then when you get to evaluation, you package all those things together as you package all of those things together as a benefit cost ratio and things like that. And I think this will become more clearer when we do some more examples of that as we move forward. Sorry, Isabella and Dana, I know you guys joined back. You're in the room. I was just answering a question from Brian, which I recorded, so you can watch it later as well. Does that answer your question, Brian?
Yeah, thank you.
Okay, you're welcome. Thanks for asking. Okay, so now I'm going to pause the recording and then